Hello everyone, welcome to Aionlinecourse. Today I'm going to show you an amazing AI project, HyDE-Powered document retrieval using DeepSeek. This project lets you upload any PDF, like Tesla's financial report, and then the AI can generate a hypothetical answer. This project fixes a major issue in vector search. If your document doesn't contain the exact keywords, normal search fails. HyDE solves this by generating a hypothetical answer first, then finding the closest match in your PDF. So you get better context, more accurate answers perfect for research, Q&A, and chat with PDF tools. How to find the HyDE-Powered document retrieval using DeepSeek. In the Google search bar, type HyDE-Powered document DeepSeek and press enter. Look for the result from Aionlinecourse.com. The title usually appears as HyDE-Powered document retrieval using DeepSeek. Click on that link. This will take you directly to the project tutorial page. Explore the project. Now scroll through the page to see the full project explanation, the code installation commands, example usage, and step-by-step guidance. Now I'll explain all the project code line by line, so anyone can understand how it works. Let's go. Here, we are installing all necessary libraries, such as LangChain, FAISS, transformers, PyMuPDF, and more. These packages allow us to process PDFs, create embeddings, run vector search, and load DeepSeek or Qwen models. We import all the core tools for our HyDE document retrieval system. Load a PDF extractor, a text splitter, and a HuggingFace embedding model to turn text into vectors. FAISS is imported to store and search those vectors quickly. We also load the DeepSeek language model for generating hypothetical answers and PyTorch for fast GPU acceleration. It connects your Google Colab notebook to your Google Drive. It mounts your drive at the folder Content Drive, letting you read from and write to your Drive files directly from Colab. This line sets a variable PDF path to the location of our PDF file in Google Drive. You can use this path later to load the PDF into your program. Here, we present our Tesla PDF. We set model name to a specific HuggingFace model called DeepSeek DeepSeek R1 Distill Qwen 1.5b. We load its tokenizer using AutoTokenizer from pre-trained, which turns text into a format the model can understand. Next, we load the language model with AutoModel for Causalum from pre-trained, letting it use the available device and run faster with 16-bit precision. Then, we create a simple text generation pipeline with Pipeline, which combines the model and tokenizer for easy use. After that, we can generate answers or text by giving a prompt to LLM Pipeline. PDF text often contains unwanted formatting, such as tab spaces, and helps clean the extracted text by replacing those tabs with normal spaces. Better text quality leads to more accurate embeddings and better search results. It processes the entire PDF, loads the text, splits it into overlapping chunks, cleans them, converts each chunk into embeddings, and stores everything in a FAISS vector database for fast similarity search. FAISS performs semantic search to find the top K chunks that best match the meaning of the question. It returns the most relevant parts of the document based on semantic similarity. We bring HyDE into action by first generating a hypothetical answer to our question and create a richer, more detailed version of the query, which helps the vector search understand the context better and retrieve far more accurate document chunks. Here, first generates a hypothetical answer for the query using the language model. It then retrieves the top k most similar documents from the FAISS vector store based on that hypothetical answer, and returns both the documents and the generated text. Check verifies whether the PDF file exists at the path stored in PDF path using os.path.exists. If the file is found, encode PDF is called to convert the PDF into a FAISS vector store for semantic search. The resulting vector store is saved in the variable vector store. After successful encoding, a confirmation message is printed indicating that the PDF was loaded and processed. If the file is not found, an error message appears asking to verify the file path. We set a sample question in test query about Tesla's factory production, then call the retrieve function, which generates a hypothetical answer using the language model and finds the most similar PDF chunks in the FAISS vector store. The results are stored in retrieve docs and hypothetical doc. The generated hypothetical document is printed and formatted neatly with line breaks every 100 characters for readability. Here, prints each document retrieved from the FAISS vector store, labeling them as Context 1, Context 2, etc. Each document's text is formatted with line breaks every 100 characters for easier reading. A new question is set in test query, asking about Tesla's Q3 2024 revenue. The retrieve function is then called to generate a hypothetical answer and fetch the most relevant PDF content from the FAISS vector store, storing them in hypothetical doc and retrieve docs. Finally, model-generated hypothetical document for the new query is printed, with the text formatted using line breaks every 100 characters for easier reading. The project enables accurate and efficient PDF question answering, transforming complex documents into instantly searchable knowledge with AI-powered insights. If you want to explore this project yourself or try more exciting AI projects, make sure to visit Aionlinecourse.com. Don't forget to like, share, and subscribe for more AI projects.